Hello students, today again we'll see the one more important topics of the unit number 5 is effects of the alloying elements. Alloying elements, that is, the first effect is the solid solution strengthening, second is the formation of carbides, third is the formations of inclusions, oxides, formations of the intermediate compounds, fifth shifting and lowering of critical cooling rate, 6 is the changes in volume during transformations, and 7th is the other effects. As we know, the alloying elements like nickel, manganese, chromium, if added to the steel, it enhances the mechanical, thermal, magnetic and resistant properties. As you know, we have seen in the iron carbon diagrams, there are two types of the ferrite. First is the alpha ferrite and second is the delta ferrite. Ferrite is almost a pure iron phase. It exists at room temperatures. The solubility of carbon is 0.008%. The solubility of carbon is 0.008%. Then the alpha ferrite at room temperatures will forms. Now the solid solutions will first see the solid solution strengthening. Alloying elements are soluble in ferrite. If the alloy elements are added in the steel, it forms the solid solutions with that ferrite. Solid solutions are harder and stronger than the pure metals. If you see the figures, see, this is the diagram. X-axis indicates the alloying elements in alpha iron and the y-axis indicates the hardness. Now we'll see the different alloying elements: silicon, phosphorus, manganese, nickel, molybdenum, vanadium, tin and chromium. You see, if there is the very low percentage of the alloy elements in alpha iron, the hardness will be 50% for the phosphorus, silicon and manganese. If we add the silicon, manganese less than 2%, there will be the greater hardness. And similarly, if you see the molybdenum, vanadium, tungsten and chromium, as the percentage of this in alpha iron is increases, the hardness is also increases. Now the examples of this is the manganese for the solid solutions is manganese, molybdenum, chromium, nickel, silicon, etc. Now the third topic is the formation of carbides. Some alloying elements combines with the carbon and forms its carbides. The alloy carbides so form increases the hardness and wear resistance. The examples of this is the chromium, tin, manganese, vanadium, etc. Now the third point is the formations of inclusions. As you know, the iron ore when formed, it contains the oxygens, and when will solidifies that iron, it forms the blowholes and the pores, and because of these blowholes and pores, the materials becomes brittle. Therefore we have seen in the last topics, that is the deoxidants are added to remove these oxygens from this ore. So usually deoxidants are added to remove the dissolved oxygens from the steel. So this deoxidants combines with the melt oxygens and it forms the oxide inclusions. Hence it forms the oxide inclusions. The examples of the formations of the oxides is aluminium, silicon, chromium, manganese, etc. Now, the fourth topic is the formations of the intermediate compounds. If some alloying elements are added to the steel, it forms the intermediate compounds. Such intermediate compounds has improves the properties like wear resistance, mechanical properties, etc. And it is as per the requirement. It is formed. Therefore, the examples of this is the chromium, vanadium, nickel, silicon, etc. The fifth point is the shifting and lowering of critical cooling rate. As we'll see in the iron carbon diagram, the critical temperatures for the eclectoid point is at 727 degrees Celsius. But if the different alloying elements have the different critical temperatures, if there is, you can see there is the ferrite stabilizer, ferrite regions, and if the ferrite stabilizers is added, it raises the eclectoid temperatures A1. You can see for this iron carbon diagram, A1 is the critical temperatures at 727 degrees Celsius. But if the ferrite stabilizer, this is region is the alpha ferrite regions. If this ferrite stabilizers is added, this eclectoid temperatures, that is A1, increases above this 727 degrees Celsius. Similarly, if in this region, you can see this is the austenite. If the austenite stabilizers is added, it lowers this eclectoid temperatures. That is, if the austenite stabilizers is added in this regions, the eclectoid temperatures, which is in the iron carbon diagram, is 727 degrees Celsius, is lowest while adding the austenite stabilizers. That is, the A1 will be below this 727 degrees Celsius. Now, the examples of this is molybdenum, tin, ferrite stabilizers, nickel austenite, nickel austenite. The sixth point is the changing in volume during the transformations. As we have seen in the TTT diagram, according to the cooling rate and the cooling media, the microstructures will be changed, and similarly the hardening properties will be changed. Now, as the changes in microstructures, as we have seen oil quench, water quench, air quench, furnace quench, and the austenite get transforms into the martensite, fine perlite. Similarly, the microstructures of these austenite transformations to the perlite, martensite, fine perlite, coarse perlite, the microstructures will be different. These changes in microstructures which results in changes in the volume of the unit cells. Therefore, alloys are added to reduce the volume impact in this. So the examples of this is the examples of the changes in volume during the transformations is chromium, nickel, silicon, manganese, molybdenum, vanadium, etc. Now, we have seen the other effects is, we have seen the other, if the alloying elements are added to the steel, number of properties are changes, number of properties are improved, like corrosion resistance, creep, strength are increased of the steels. Therefore, the alloying elements improve the properties of the steel. Improve properties of the steel. These of steel like creep, corrosion resistance, creep, strength, and strength, thermal resistance, etc. Strength, thermal resistance, etc. I hope you will have understand these 7 topics which affects on the steels. If we add the alloying elements to the steels, the properties like solid solution strengthening, formations of the carbides, formations of the inclusions, formations of the intermediate compounds, shifting and lowering of the critical rate, and the changes in volume during the transformations, and the other effects will have understand. Thank you.